Okay, hello everyone. So today is the second session of our day 3 so today is our second day of this domain 3 of CISSP, which is security architecture and engineering. So here is the link of this particular PPT for today class, right? You can download the same, and as we are moving through this particular PPT, then we can you can also keeps on looking on those PPTs. If you want more details on this, you need to view the topic wise videos of this particular domain. So as yesterday we discussed about the principles of security engineering. We discussed about the principles of security, and today we will discuss how we are going to use these principles. Okay, and today is more practical session because today we will see the different scenarios, different conditions which we use or which we face on day-to-day life in our security domain, right? So in this particular domain, okay, so this is okay. Let me change this. This is older one. This is the these are the subtopics which we need to discuss. The first one is implement and manage engineering processes using secure design principles. We have already gone through this yesterday itself. We have seen the secure design principles yesterday. Today we will check out how we can, it means what are the different security models. We will see the concepts of a security model, because normally in every book you will see that these are the 5 security models or these are the 6 security models, but you are not able to see that how we are categorizing those security models. And it is very important for us to understand the same, then only we can categorize, okay, this is a security model of this particular categorization, right? So that's what we will discuss today. Then we will also see some controls, how we can select controls for this different system settings, like for the client based, server based, database systems, cryptographical controls. So we will see all these, and tomorrow we will have a class on cryptographic controls dedicated for cryptographic and site security. So these are the two subtopics. It means the cryptography, and the last one is the site, implement site and facility security control, which we will take tomorrow. But today, rest of the subtopics we will just cover today itself. So starting further, yesterday we discussed about the defense in depth model. When we are talking about defense in depth model, then the most important thing is where exactly the asset we are placing. So in defense in depth model, we are placing the asset at the central point, and we are providing multiple layer of security around that particular asset itself, right? So today we will see these layers. Okay, because as a security architect, your understanding and your role is to provide maximum security. As yesterday also we discussed that security architect need to work on reducing the risk. There are 4 ways to play around with the risk, and one of the way is to reduce the risk, and it is the role of the security architect to reduce the risk, and by providing multiple controls at multiple layer, ultimately he is mitigating those risks. Okay, so moving further, security models. Whenever we are saying security models, then we are having a subject which we need to give some privileges, and an object to which we need to provide the security. Like any particular user who is going to access your portal or your website, then in that particular case he is a subject, and that particular portal is a object. So whenever that particular subject, it means that particular user, try to access your web server, he will just use the web pages. He will just play around inside the web pages only, and in those web pages, whatever data is there, he cannot interact with that particular data. So he need to interact with the web server, and if he requires some particular data, then the web server will fetch that particular data from the database and then give it on the front end interface to the user, right? So in that particular case, in the first case, when the user is interacting with the web server, in that particular scenario, the user is a subject and the web server is an object, right? And user is writing something on that particular web server, writing down a form which is there. He is just filling that particular form. So when he just submit that particular form, then the web server will just insert that particular data to the database server. So when he is inserting this to the database server, then automatically the web server become a subject and the database become an object, right? So subject is an active entity which manipulate objects, and objects are always a passive entity which is manipulated by the subject. But a subject can also be an object, as in this particular scenario itself, initially the web server is an object, but in the second case it is a subject. So we need to understand the same, right? Okay, moving further, when we are talking about the security models, then the security models majorly can be divided or categorized into three categories. One is a state machine model, second information flow model, and third one is a take and grant model. Why this particular categorization is? Because whenever we are going to provide any kind of security or we are going to make any particular model, we need to have some base with in our hand, and the base is, in the first case, like the state machine model, the system is always secure no matter whatever its state is. Means we are talking about a state of the system, whether it is on, whether it is off, whether it is in between the processing, right? But in the second scenario, like the information flow model, we are talking about, and we are mainly focusing about the information flow, that the information is going from one system to the other system, right? That is information flow model. And the third is take and grant model. Take and grant model is like giving access of a particular file to someone. So those kind of models, when we are going to use, then we will we call them as take grant model, right? So discussing each model one by category of the models one by one. The first category is system is always secure. It means the state machine model, in which the system is always secure no matter whatever the state of the system is. Second, it's always boots into a secure state, maintains a secure state across transitions, one state to the other state also. Whenever it is going, then also it will maintain the secure state, and also allows the subject to access resources in a secure, compliant manner by security policy. Okay. Next is the information flow model. When we are talking about information flow model, it is focused on flow of the information. It is designed to prevent unauthorized, insecure or restricted information flow between different security tiers. It means tiers here means the clearance we are giving to those subject and objects. Okay. Then comes it establishes relationship between two versions or state of an object at different point of time, right? And the third model is a take grant model. When we are saying about we are discussing about take grant model, take means take control of an object and grant means granting right to an object. Okay. So in this we need to create, it means we need to allow the subject to create new rights. Okay. And we need to remove, it means what we need to remove? We need to remove the rights. If we have given any subject any right, then we can remove those also. So in take grant model, normally we create and we remove the rights. Moving further is our first security model, and that particular security model is Bell-lapadula. When we are talking about Bell-lapadula, is mainly focused on confidentiality. In this particular slides and in this particular video, I'm mainly focusing about the exam. So whatever the types of different types of questions that are going to come in the exam, I have made these particular slides as per that only. So I have given minimum information, but that particular minimum information is majorly focused on the questions in the exam, right? So Bell-lapadula model is focused on confidentiality. The idea behind this Bell-lapadula model is to ensure that data is not leaked among clearance levels by restricting higher clearance subject from writing down or leaking information to lower clearance objects, and lower clearance subject cannot read or view higher clearance objects in Bell-lapadula model. It means what? It means that a trusted subject can violate the star security property. We will discuss what exactly the star security property is. Star security property is no write down. It means a higher clearance object cannot write something on a lower clearance subject also in the event of a declassification. So, and it is we call it as a MAC, mandatory access control. And mainly this particular model is a information flow model. As we have already discussed that here we are focusing on confidentiality we are focusing, and whenever we are talking about the subject and object and the flow of information in between them, that what Bell-lapadula model covers, and that's why this particular model is a information flow model. So there are three important things which we need to know about this particular model, and these three properties are simple security property, star security property, strong star property, right? So the first property, simple security property, it says no read up. Subject cannot read higher than the clearance but can read down. Okay, so if any particular subject is having a higher clearance, then that particular subject cannot read more higher than that but can read all the below one. Star security property, no write down. Okay, like the stars they are in the sky, so we can just correlate this for our understanding only. There is no correlation in this. Just to remember for the exam, we can say the star security property. Star security property says no write down. Okay, subject cannot write to lower clearance levels but can write up. Okay, so as not to leak data writing to a lower level, it can violate the declassification, because in declassification the higher level information cannot go to the lower level. Okay, then comes the strong star property. Strong star property says no read, no write up or down. It means a subject with read or write cannot read or write above or below the clearance level. Only they can write or read within the same clearance level. That's what the strong star property is. So it is very important to understand these three properties of the Bell-lapadula model, and for the BIBA model also there are three properties. These are, first let's discuss what exactly BIBA model is. BIBA is, as this Bell-lapadula is mainly focused on confidentiality, BIBA is mainly focused on integrity, right? The idea behind is to ensure that the data is trustworthy always. Okay, a higher clearance subject cannot read a lower clearance untrusty object, and a lower clearance subject, untrusty, which is again a untrustworthy, cannot modify write to a higher clearance object. Okay, that's what BIBA model says. So it prevents unauthorized modification by authorized subjects. Also, it prevents modification by unauthorized subjects. It protects internal and external object consistently, and again there are three properties in this. The three properties are simple integrity property, star integrity property, and invocation property. So in simple integrity property there is no read down. Subject cannot read lower than the clearance level it has assigned. Then the star integrity property says no write up. Subject cannot write higher than the clearance level. And the third one is the invocation property. So any process cannot call upon request subject at a higher clearance. It means any process cannot call or request access of any particular subject with a higher clearance level. That's what the third property, invocation property of BIBA model is. So these are the two security model, and again this particular security model is what? This is again a information flow model. Okay, then comes the Clark-Wilson model. In the Clark-Wilson model, we can say it is mainly focused on the integrity. Like the BIBA model is also focused on the integrity, this is also focused on integrity itself. So it ensures security by using three-part structure with security labels. It means here we need to give the security labels, but in the previous one we are not giving any security labels, but here we are giving security labels. So we are using a labeling concept of the principles which we have discussed yesterday. So in the subject will interact with an interface which will further interact with the object. I'm just taking one example here. As a firewall, we can take we are having to access any particular firewall. First, what exactly we are doing? We are accessing the management console of the firewall, and whatever changes we are doing on the management console. So, and then finally those changes will be implemented on the firewall, or that particular data will be fetched from the firewall and represented on the management console. So that's what our interface. So this management interface, the management console of the firewall is the interface which we are getting in between that. And our object here is the firewall, and subject the user who is using that particular management console. So a data entry operator, the second example you can also take a data entry operator who modifies the database using a web interface. That is also using the Clark-Wilson model. So in this particular interface, we can put more restriction, we can put the rules, we can put more security on the interface itself. Okay, so we will discuss what exactly security we can implement on any particular interfaces. That it means whatever the security controls we can implement on any particular web interface, we can implement, we can put all those restriction security control on that particular interface itself. So this Clark-Wilson model, it enforces well-formed transaction and separation of duties. How? Because it prevents unauthorized subject from making modification, first thing. Second, it can prevent unauthorized subject from making unauthorized modification to object, because in the interface itself I can restrict that user can need to give a command but should not have these command in that, right? So I can just restrict the user behavior, user interaction of the with the interface. And the third, it can also give separation of functions. It means different functions will be available to user based on class of the user. So in the this firewall management console itself, I can say the admin console will have these much of features, and a normal user will have this much of features. And a normal user who just want to view some information, then he is having the list privilege, so he will have this much of information, right? So using this Clark-Wilson model, we are providing both well-formed transactions and separation of duties. Then there are some common model in commercial system. This is very common. Clark-Wilson model is the most common model which we are using in commercial system, like SAP, like as we discussed, the firewall management console, and even other consoles also. So everywhere this is the most common model we used. And in this most common model, there are some procedure and there are some items. So the procedures and items are CDI, UDI, IVP, and TP. These are the some common procedure and items. CDI means constrained data items. It means any item whose integrity is protected by the model. UDI means unconstrained data item, any data item whose integrity is not protected by the model. Then IVP, integrity verification procedure, scans data items and confirms their integrity. And the last one is transformation procedure. Only items that are allowed to modify CDI is TP, transformation procedures. So when we are talking about the web interface, web application, normally we use all these items and procedures. Maybe the naming is different, but the processes are the same. Okay, moving further, we need to understand two more models. One is a Brewer-Nash model and other one is a access control model. Brewer-Nash model we also call as Chinese wall model, because it is used to design to avoid conflict of interest, like the China wall. Same way, it also prohibits access to a subject like a consultant from accessing multiple conflict of interest categories. Okay, and then the Brewer-Nash model requires three things. It requires properly identified subjects. It means also it also take care of the subject and objects. So it requires well identified subjects. First thing, it also requires one or more data sets. And the third, the class definitions related to the conflict of interest for all the data set, it also required the same. So the next model is the access control matrix. I have given a detailed videos of each and every model because these are topic by topic. So that's why if you want to go in much more depth and if you want to see the practical implicity of all these models, then you can watch my videos, which are topic by topic videos in the CISSP series itself, because in the whole day it is not possible to cover everything in detail. That's why I'm just giving an overview. It means, as I told you in the very first day, that we are creating a framework in day by day. So because the framework will give you an understanding, and in that particular framework, either from the book or from the videos, you can keep on filling the gaps, and then you will have a complete understanding, right? So the next model is the access control matrix. In the access control matrix, the table that defines access permission between subject and object. Like normally we are creating a folder, okay, and in that particular folder we are giving some rights, like the read write access, and if it is a file, then we can also give a execute permission also. So while giving these permission, we can create a matrix. We can create a matrix, and in that particular matrix, at one point, at one side we can put all the subjects, and on the other side we can put all the objects. Okay, so any particular user A can have full access of the firewall, admin access of the firewall, but to a particular folder he can have a read and write permission only, but to database he should not have any access, right? And second subject Y can have a complete admin access of the firewall, but he is not having any access to the folder, but maybe he is having the full access of the database also. So in this way you are creating a matrix, and using that particular matrix you can say, okay, everything is between the subject and object is mapped. That's how the access control matrix is functioning. But remember, there are two more things. ACL are object focused, okay, and has a list of subject who are granted access to the object. So when we are putting the ACL we cannot put in the access control matrix, because ACL are always object focused. It is not talking about anything about the subject. And capability table is subject focused and has a list of action that a subject can perform. Okay, so these are two important things which need to be taken care in respect of the exam. Okay, so when we are talking about the models, security models, then there is one more categorization of the same, that is access control model. Access control model mainly deals how exactly the subject is going to access the object. Okay, and these models can be divided into majorly two categories. One is DAC, other one is this NDAC we call it. DAC means discretionary access control, and NDAC means non-discretionary access control. But NDAC can have multiple further submodels. Like in this particular PPT I have shown you that the green color is DAC, and all the blue colors, all these lie in the NDAC. It means all these are non-discretionary access control models. So let's see what exactly discretionary access control means. In discretionary access control, security of object is at the data. It means owner's discretion. So access granted through ACL, and also the owner of the object decide what permission he want to give to any particular subject. Okay, then it is identity based. Okay, because A user can have the full access of this particular file. B user should not have any access of this particular file. Subject has no knowledge of the object sensitivity in discretionary access control. Also, it is very scalable and flexible, as each owner decides the access by himself. Okay, that's what discretionary access control is. Then we are talking about non-discretionary. Then the first is mandatory access control, MAC. In this, data owners cannot grant the access. Security labels of subject and object define the decision of the access. So the access granted by a centralized security officer. So the subject label must dominate object label always. Subject has knowledge of the object sensitivity. Also, a lattice based access control can be made using mandatory access control. It can be compartmented further for label plus compartments, which helps you in the concept of need to know. Okay, then it enforces confidentiality. So the main role of mandatory access control, MAC, is to enforce confidentiality. The next model is RBAC, role-based access control. So the role-based access control is again a non-discretionary access control. It means it is group-based access permission. It is each role has a set of rights over objects as defined by the data owners. The security admin configures the rights, and the subject is the main focus here, right? The third one is rule-based access control. Here we need to create rules which are global focused rules that apply to all the subjects, and we call them as restrictions or filter, like in a firewall. The next is attribute-based access control. Attribute-based, like in SDN, software defined networks, we create some attribute that whoever is going to access this particular network, he should have these conditions. So what we are doing, we are setting the attributes, the policies that include multiple attributes. Attribute for rules, like the system should have this particular name, series should be from this particular series, the system should have windows of this kind. So we can, in SDN, we can give all these rules. So we call it as attribute based access control. Okay, so once you have the understanding of the access control models, then again we need to have an understanding of the requirements of a security system. So whenever we are saying the requirements of a security system, it means information system architecture must meet the business and security requirement. Yesterday also we discussed about all these 4 requirements, but today also I am discussing the same because it is most important. After understanding of the principles, you should go through the requirement of the security system. And again, after going through the models, you need to understand the requirement of a security system. So security should be built into information system by design itself. Also, security must be balanced the business requirement and the security of the system. And trade-off will be needed between security and business to achieve a balance in between them, right? So moving further, let's see the criteria which define security in any particular product itself. Like initially we have, this is as per CISSP syllabus only I am going through. We have TCSEC and ITSEC. These are the 2 standards via which we can say that this particular product is this much of secure, or this particular environment is this particular secure. And this gives some numbering, some criteria, some identification object, so that any particular object can be identified that this is the number it is having, so it is this much particular secure. So if anyone is having a A, it means it is verified and protected. The whole TCSEC is based on the orange book, right? And if any particular model, so I have given some divisions here, division of class A, B, C and D. Like class A means verified, the protection is well verified, it means the whole design is verified if it is A1. If it is division B, that is mandatory protection. If it is B1, it is labeled security protection. B2, structured protection. B3, only security domains are verified to be protected, which are as a mandatory protection mechanism. And if it is division C given to something, then it is discretion security, means C1 means discretionary security protection only, but in C2 it is controlled access protection. And if it is D, then the particular object is having minimum protection, right? So it is a European ITSEC has they have given the first model on this evaluation model. So any particular security product can be evaluated based on these particular models. So they have given like functionality. They have given symbol F for functionality. It means how well a system works in implementing the security or in terms of security. And assurance also. Assurance tells us the ability to evaluate. Assurance is measured by effectiveness Q and correctness E. So the class rating are compared in follow-up sections, in which additional functionality ratings include F means high integrity requirements, AV means high availability requirements, TI means high integrity, DC means high confidentiality, and DX means high integrity and confidentiality for network. Okay, I'm explaining all these things, but in terms of for the exam, you just need to understand that you need to understand TCSEC and ITSEC model, that's it. And these 2 models are only for evaluation purpose, nothing else. It means whatever the security product is going to come in the market, before that it should be evaluated, then only anyone will trust that particular model. So these are the 2 models, TCSEC and ITSEC, and in these 2 models they have given some divisions. Depending on those divisions, they can just verify, okay, this particular model is having this criteria, then it must be this much of secure, and it is tested for this much of security, because it is not possible to test each and every product in every environment. So that's why we will go through some standards, and TCSEC and ITSEC are some of the standards. But as of now, currently, we are not following the TCSEC and ITSEC majorly. We are majorly going towards the common criteria. Some of the countries, they have already implemented common criteria. Some of the countries, they are in the process of implementing common criteria. So this is the current standard using which we evaluate the products. And these standards means have some basic terms to understand. These are target of evaluation, protection profile, security target, and evaluation assurance level. Okay, so the target of evaluation means system or product that is being evaluated. We call it as target of evaluation. Protection profile means the independent set of objectives and requirements for a specific category of product or system, such as encryption software or firewall. So that is, for them we will create a protection profile and we will test that particular product. Product is here the firewall or the encryption software is the product, but for them we will create a protection profile. Then protection profile is I want from a customer perspective, like from a firewall, I want the firewall to protect the traffic from coming into my environment. I want the firewall to protect to itself from the DOS attack. So all these are the protection profile, which will be, all these statements will be added into the protection profile against which that particular product will be tested. Next comes the security target. When we are talking about the security target, it is the documentation that describe the target of evaluation within the security requirement and operational environment. So security target is the what I can do from the vendor perspective. So in security target, the vendor will tell my firewall can do this, my firewall can handle this much of traffic, my firewall can handle this much of DOS attack, my firewall will have this much of I can say error rate, right? So all these parameters will be given by the security vendor. So the security vendor will set a security target. Then as per the common criteria, we need to create a protection profile, that this is the protection profile against which this particular security target will be evaluated. And then in that finally what we need to evaluate the object, and the object here is the firewall, application software, whatever it is, then that will be tested on that. And finally the final term is evaluation assurance level, the evaluation score of the tested product. Finally, after doing all the tests, they will give a final assurance level, and the assurance level can be EAL1 functionally tested, EAL2 structurally tested, EAL3, 4, 5, 6 and 7. 7 is the highest one. It means it is formally verified, designed and tested. It means everything is formally well tested from the design till the final testing. Everything is well tested. Okay, so when we are going to purchase any particular product from the market, we need to check for the common criteria. What exactly the common criteria they have given, the vendor has given to that, because as per that only we can get the assurance that whatever the vendor is saying, whatever the vendor is giving in their specification, whether it is meeting or not meeting them, and if it is meeting, up to what level it is meeting. Okay, so moving further, we can have a I have given a comparison table here, in which you can see a comparison between the TCSEC, ITSEC common criteria and the description of the same. So it is very helpful in the exam. So you can say that the A1 level of TCSEC is equivalent to EAL level 7 of common criteria, and for the ITSEC it is FB3 plus E6, right? So you just remember this particular table, just mug up this particular table, because sometimes they require this thing in the exam also. They will give a question that if any particular product is of EAL2 category, what exactly it means. Then you can say it is discretionary security mechanism they have tested for, right? Okay, moving further is certifications and accreditation, or we can say certification versus accreditation. So three things we need to understand: what exactly certification means, what exactly assurance means, and what exactly accreditation means. So certification is, it means to certify to meet security requirement of the data owner. It considers the system, security measures and the residual risk, like certified by the manufacturer to state what the system does. It means the OEM, they can give their they certified, self-certified that our product is able to do this, right? Then assurance. Assurance means systems have designs accepted, development stage well analyzed, reviewed, tested and evaluated. Assurance is by some other party. They are assuring, they are saying, yeah, this particular product is well tested and it is well tested in a particular environment, and it is, you can have assurance on this, right? That is assurance. And the third one is accreditation. It means the data owner's acceptance of the certification and the residual risk before the system is put in production, right? So the certification is from the vendor end. Assurance is from the third party, like the CC criteria we have taken. We have taken the assurance from them that they have tested the product from in their particular facility in a well-defined way. And then finally, when we bring that particular product in our environment, then before putting into the production, we will test into the QA environment, and then we will finally accredit it that yes, it is meeting all the requirement, and finally we can put the same in the production. So it is having 4 phases in total. These 4 phases are: phase 1, definition. We need to define that, we assign some appropriate personnel for that particular thing, we document the mission, we document the goal, we put the system characteristics, everything we put here. Then finally verification. In the verification phase, we refinement of whatever we have defined in the definition phase. Then finally validation. We need to verify that this is my requirement or my definition, whether this particular product is well validated for the same or not. And then comes the post accreditation. It means maintenance, or system operation, change management, compliance validation, all those are covered in this particular phase 4, right? So in each certification till the accreditation step, these are the 4 phases: definition, defining the scope and everything, then verification of those whatever we have defined, then validation, whatever we have defined are working fine or not, and finally post validation, maintaining the same. Okay, next comes, okay, as I already told you that this particular domain is more about the security architecture, and when we are talking about the security architecture, he need to have a clear understanding, it means a in-depth understanding of the computing model. And when we are saying the computing model, means the complete trusted computing base, the TCB, we call it as TCB. TCB means trusted computing base. It means every system should depend on or should work on a trusted computing base. What exactly it is? It means the system should have a security parameter, it should have a reference monitor, also it should have a security kernel, right? The security parameter, it delineates the trusted and the untrusted component within a computer system, and it isolates the TCB. I will show you a diagram here. So this is a complete user space. In this particular user space, there are some user process, and there is a reference monitor and a TCB. TCB is trusted computing base. So the TCB, our TCB is around the reference monitor. So this is our, over the TCB is our security perimeter, and finally the security kernel. So the reference monitor, it will just abstract the machine concept that mediates all access between subject and the object. Also the reference monitor will define the rules, like the laws. We can see the ACL here. So all the ACLs will be defined at the TCB. Then comes the security kernel. The security kernel, it enforces the reference monitor concept. Also it must facilitate isolation of the process, and it also enforces the rules defined by the reference monitor, right? In terms of the exam, I just want to tell you, just remember this particular diagram, that there is a user space. In that particular from that particular user space, the user process will run, okay, which is outside the security kernel space. Okay, so the user will interact inside the security kernel, and inside the security kernel there is a final reference monitor and the TCB, which is in both of these are inside a security perimeter. The security perimeter ultimately will have all the security implementation, like the ACL and everything will be implemented in the reference monitor. So in the exam, they will directly put a questions. They will either give you this diagram or some other diagram, and then they will ask where exactly the security perimeter will be. Like that, you can get questions in the exam, right? So with this, I want to say that any particular system, be it a mobile phone, it means any IT systems, whether it is a firewall, whether it is a system, whatever it is having some states like dedicated mode, system high mode, compartment mode, then multi-level mode. So each mode have some functions, like dedicated mode. In dedicated mode, it is a single state system. System is having only a single state. User must have clearance that permit access to all data processed by the system in dedicated mode. Also in dedicated mode, the access approval for all data is required. Okay, and then the user must have a valid need to know for all the data in dedicated mode. But in system high mode, user must have clearance that permit access to all information processed by the system, and he also should have access approval for all the data, which is same as the dedicated mode, and user must have a valid need to know for some data processed by the system. Then comes the compartmented mode. In compartmented mode, user must have clearance that permit access to all information processed by the system. Also, the access approval for data they need to access is required in compartmented mode. Also, the user must have a valid need to know for all the data they need to access in compartmented mode. Then the multi-level mode. Multi-level mode means system can have multiple state systems. Okay, the subject does not have clearance to all the data processed, right? Each state will have different clearance here. So the subject clearance dominate object label here. User need to have approval and need to know for only the data they need to access. So these are the 4 different system modes which we need to understand in terms for the exam. Moving further, we need to know the CPU also. When we are talking about the CPU is central processing unit, as everyone already knows this thing. But this central processing unit, it also have some different way of working, like multitasking, multi-threading, multi-processing, multi-programming, and multi-core. So we need to understand these also. Like in multitasking, it can handle 2 or more tasks or process simultaneously. In multi-threading, it distributes multiple tasks inside a process over 2 or more cores in parallel. And in multiprocessing, it uses multiple processors with multi-threading application to achieve computing. So it means it combines the upper 2 all together, right? So it can do the same in 2 ways, like SMP, symmetric multiprocessing, where a single OS but multiple CPU on shared memory and data bus are used. Other one is MPP, massively parallel processing, one OS per CPU with software that coordinate activities and processing within them itself, right? Then comes the multi-programming. It emulates multitasking. When one process waits, another runs on the particular CPU. That's what we call as multi-programming. And finally is multi-core, which is independent cores that operate and process simultaneously. That is multi-core. So I have given a diagram here. In this particular diagram, it is we have given a ring architecture of the CPU. In the ring architecture, the ring 0 is the kernel mode, which is having the most secure security. So that is the most secure layer. So OS performs privileged instruction via system call only with ring 0. Ring 1 is OS component. So over the next layer is the OS component. That is the ring 1, which is having the less security than the layer 0, but having more security than the ring 2. In ring 2 we have the drivers and the protocols, and in the ring 3 we have the user mode. Okay. Okay, I think I am having some issues. I think I got a connectivity issue, and in between the connectivity breaks, but I think it is it resumed again. So I'm just starting from here itself. Okay, so this is CPU we have already discussed, and next comes the open states. Okay. Also, we need to understand the CPU cycles. It means how exactly when the CPU is working, we need to understand the same also. To understand the same, we need to understand 2 things: the CPU cycle and the CPU states. When we are talking about CPU cycles, there are 4 CPU cycles: fetch, decode, execute, and store. Okay. So when we are saying fetch, in fetch, it gets the instruction from the memory, and just it means the only work the CPU will do, it will just get the instruction from the memory. We will discuss what are the different kinds of memory later on, but we are just talking about the Okay, next comes decode. Decode means to decipher and the instruction and send to the ALU, arithmetical logical unit, for execution. And the third stage is execute, where the ALU performs logical operation on the data. And finally store. So these are the 4 CPU cycle. In store, the result of the logical operation is stored in register. Okay. Next comes the CPU states. When we are talking about the CPU states, there are 4 CPU states which I have given in this particular 5 CPU states which I have given in this particular slide. The first one is ready, waiting, running, supervisory, and stopped. So ready means the process is ready to begin processing and CPU is no, but the CPU is not available. So it should be in the ready state and it should wait for the CPU to be free. Then comes the waiting. The process is waiting for the device or access request. So it is kind of an interrupt. So in between, if the execution of any particular instruction requires something, then it will put that particular instruction into the waiting state and wait for that particular data from that particular memory or that particular external device to continue that for further processing. Then comes the running state. So running is the process is executing problem state in which CPU is trying to solve until it's solved, blocked or time sliced. It means the time already expires. Next is the supervisory state. In supervisory state, the process requires greater privileges. Any function not executing in ring 3 comes under supervisory state. And the final CPU state is stopped. It means the process finishes or terminates in between, right? That's what these 5 states are. So when we are talking about CPU, then the CPU will interact or take the data from the memory. But when we are talking about memory, memory can further be classified. And the most important classification is ROM, PROM, EEPROM, flash memory. The reason for this ROM, PROM, EEPROM is, okay, ROM is read-only memory. It is non-volatile memory. Content burned in at the factory itself. It is not modifiable. Next is PROM. PROM means programmable read-only memory. It end users OEM burns in chip content. Okay. Okay, right. And it is only allowed once. It means once it is burned, then finished. So you will find microcontrollers in the market which are PROM based, programmable read-only memory based. Then comes the EEPROM, which is electronically erasable PROM. It can be erased and rewritten via electronically voltage. Only full erase and write functions are available. We are using, like, some of the microcontrollers are EEPROM based. We can just reset them and then use them again to program it again, right? Then comes the flash memory. Flash memory is majorly NAND flash. We can say it is it is completely based on the NAND gates and can be written and erased in blocks. So a single file write and deletes is a basic property of flash memory. Let's see the further classification and where exactly we are using these. These are cache, registers, static RAM, dynamic RAM and flash memory. So in any particular system, we use the memory for different purpose, and the location of the memory and the speed of the memory is very important for that particular purpose. Like for the CPU, when any particular memory is near to the CPU, and if that particular memory frequency, it means the memory speed is not that much particular fast, then that is of no use. Even if the CPU is having very high processing power, but it requires a equivalent memory, which is equivalent fast memory, which can just capture that particular thing, and then it will just give the whole detail to the CPU. And that's how the cache come into picture. So it is a volatile memory and it is used to store frequently accessed data from the CPU. So CPU have two caches, L1 cache and L2 cache, which are registers. Normally in behind, cache means registers only that store information which the ALU executes. Then comes registers. Any data that ALU, arithmetical logical unit, manipulate must be inside a register only. And then comes the static RAM. Static RAM, these are the flip-flops to store volatile data. These are refreshed at power outages. So it is quite expensive, static RAM. Then comes the dynamic RAM. Dynamic RAM normally we use previously in this RAM, random access memory, which we use in the system. So it uses register to store volatile data. CPU must constantly refresh via electrical voltage. It is very inexpensive. That's why we are using it as a RAM in our system. Then comes the flash memory. So flash memory is the pen drive which we are using. So it uses NAND flash, okay, and can be written and erased in blocks. So single file write or delete are some of the functions in this. Moving further is memory categorization. So memory can further be categorized like primary memory, secondary memory, volatile memory, non-volatile memory, random access memory, sequential access memory, right? So we need to understand this categorization also. So as per this categorization, the primary memory is readily available information we will store in the primary memory, and it is accessed by the CPU. So it is temporary. Example of the same is RAM. Then we have secondary memory. So long-term storage we will do in the secondary memory. Normally it is very inexpensive, very cheap, like the hard disk, the SSD, the tape, magnetic tape, all these comes under the secondary memory. Then comes the volatile memory. So any memory when categorized as volatile memory, it means it is temporary memory. It will be wiped out once the power is lost. Example RAM. And the next is non-volatile memory. It means long term, it retains data. Example are HDD. Okay. And next comes next categorization is random access and sequential access. Random access, hard disk you can take an example, RAM you can take an example, pen drive you can take an example. Pen drive is a flash memory only. So information can be accessed randomly. And sequential memory, every tape memory, wherever we are using tape, whether it is LTO tape or whatever the tape is, we are using a sequential memory only. Okay, moving further is how we do the memory addressing. So when we are talking about the memory addressing, there are different kind of addresses available, like the register addressing, the immediate addressing, the direct addressing, the indirect addressing, the base offset addressing. Okay, what exactly these means? When we are talking about the register addressing, it is used by the CPU to access one of its register to store access data in the register. Then comes the immediate addressing. In immediate addressing, instruction supplied as part of a command that does not require the CPU to fetch anything. Okay. Next is direct addressing. Direct addressing is CPU is given the memory address to fetch the instruction. Other one is the indirect addressing. In indirect addressing, CPU is given a memory address to another memory address that has the instruction. And the last one is the base plus offset addressing, which uses a value stored in a register as base and begin counting using the offset itself. Right? Okay, moving further. So it is very important for you to understand these addressing types. That's it. Nothing more is required. Do not go in depth in these. Just remember that there are the 5 different types of addressing, memory addressing, and what exactly they means. That's it. Do not go in depth in this. Okay. So when we are talking about the security architecture, as we yesterday also we discussed that we need to implement these security principles somewhere, and while implementing these security principles, these are the some of the security protection mechanisms we are having by using those principles. So we need to understand these security mechanisms like layering, abstraction, data hiding, process isolation, security domains, hardware segmentation, principle of least privilege, separation of privileges, accountability, right? And we with this 2 more separate mechanisms are also there: data execution prevention and address space layout randomization. Okay, taking all of them one by one. Layering, defense in depth is the perfect example of the same. We are providing multiple layers of security in defense in depth. The most privileged threats are processed in the inner layer, like the ring model. Okay, next is abstraction, where the subject does not need to know all details, such as how it works of an object. We call it as abstraction. Next is data hiding, which prevent one class from accessing or viewing data of higher class. In process isolation, next is process isolation. The processes are executed in different memory spaces in an operating system so that they do not interfere with each other. Okay, so the OS provide process isolation in normal environments, and VM environments, it is the hypervisor which provide this process isolation. So in security domains is the next security mechanism. Security domains means grouping of subject and object with similar security requirements together, right? The example of the same is kernel mode and user mode. And the next is hardware segmentation. In hardware segmentation, the hardware is segmented based on function. So the segment VMs to hypervisor based on the function only. Then the principle of least privilege come. So it means lowest privileges will be given as per the need, right? So next is separation of privileges. Separation of privileges means different tasks like the security admin, network admin will have different goals. That's why they will be assigned different privileges. And the next is accountability, which means audit logging, usage recording, all these comes under auditing. Okay, so two more are there: data execution, which is to prevent processes from executing instructions in memory location that are not predefined in the code. And the last one is the address space layout randomization, which randomize executing memory space of the program. The benefit of the same is, I'm just taking an example. Suppose an attacker develops an exploit on his PC for a memory address. That particular exploit will not work on a client or a server. The reason for the same is there is an address change in between the attacker system and between the main server, right? So moving further, how we can provide protection to hardware systems. We can provide protection to the storage media. How? It means we will see when we are talking about the storage media. Storage media means the hard disk, pen drive, everything, where we can store that particular media. It means the secondary storage which we have discussed for. So the storage media data reminiscence problem is there. To protect it from the same, we can use the sanitization, as we discussed yesterday also. Then there is a second I can say threat, that is theft or loss. And if there is any theft or loss, we can protect the storage media or the data inside that particular storage media by using encryption. The third threat can be, or the third issue can be, unauthorized access of the storage media. So we can put strong identity controls to protect the storage media from the same. Next hardware system which we need to protect is monitor. So for monitor, there is a temp test way in which data can be read remotely via electronic emanations. And to protect the same, we can use a copper or we can use a case-like structure of a metal, so that all the electromagnetic waves can be stored. It means blocked within that particular case-like structure itself. And next challenge with the monitors is shoulder surfing. When we are talking about shoulder surfing, anyone can can stand from on your back, and then whatever you are typing on this monitor, they can just see that particular thing. So that's why we need to hide. We can just user awareness is the best thing to protect any user from shoulder surfing. The next comes the printers. So while we are taking the print, then normally suppose I give a print of any particular document from my system, and then automatically the printer will print it, and then that particular document is still lying on that particular, and at that moment itself I got a urgent call. So while I'm attending that particular call, anyone can see that particular printed document on the printer. So we can print the we can secure our environment from this is on giving authentication to the output tray. It means the user need to go to the printer, they need to pin a user ID and password, and then only the printer will print that particular thing. And the second for printer is anyone can sniff the data which is going to a network printer. So we need to transfer that particular data in an encrypted form. Next hardware which we want to safeguard or protect is keyboard and mouse from keyloggers, Bluetooth, RF interception, and temp test. So these are the three things which we need to protect against for this particular hardware. It means we need to protect the mouse and keyboard from keyloggers, Bluetooth and RF interception, and temp test. Okay. Next is BIOS and the UEFI. So there is a common problem that a malicious BIOS can be flashed into the EEPROM, and once the system will boot, then it will take the control of that particular system or further infect that particular system. So using a strong authentication mechanism or using a strong physical access of that particular system, we can protect the system from BIOS level attacks. Okay. So forensic disk controller can be used to protect data protection on disk and storage devices, right? With this also we can use a forensic disk controller to protect the data operations on disk and storage devices also. Okay. Moving further, protecting the client-based systems. When we are talking about the client-based systems, then we can use applets, we can use the cache poisoning technique, we can use the Java, ActiveX, ARP, and DNS. So these are the 5 or 6 things which we need to take care. When we are talking about applets, it acts like a program and execute code on user machine rather than on the server itself. So it will give a very good type of protection when it means we can use the applets for the protection. Then the cache poisoning, it poisons temporary stored data to a malicious vector, right? So it modifies the DNS entry of any particular, it means our system is having a cache, right, a DNS cache. Now if anyone poison my DNS cache and change the DNS entry of google.com, so whenever I'm trying to go to google.com, it will just move my system, it will direct the traffic of my system to some other traffic. So that is what cache poisoning is. So it can be at the DNS level, it can be at the local system level. So we need to protect the client-based system from that. Then comes the Java. In Java, we normally run JVM, Java Virtual Machine Environment, which is a cross-platform method of running that particular code on any particular environment. It means Java code can be run on any particular platform because we are running that particular code on a virtual machine environment. So it operates in a sandbox environment. So it prevents the code from accessing the unauthorized resources. Okay, so there are lots of vulnerabilities related to Java. It means especially related to the JVM. So we keeps on checking for those vulnerabilities, and if it is required, we need to keep our system well updated for the same. And next comes the ActiveX by Microsoft, which runs in IE. IE is old now, but still some of us are still using it. So that's why, and in respect of the CISSP exam, it is very important to know it. So it can perform any privileged action. So we need to restrict the access of ActiveX in any environment, in our environment. Next is ARP. ARP will modify the local ARP cache to point an IP to a malicious MAC address 10 minutes till refresh. So it creates static ARP entry to point to malicious MAC addresses. Can be used to route to malicious gateway, and then finally also it can be used to do a man-in-the-middle attack. So we need to take care of ARP poisoning also. Then comes the DNS. So host file poisoning, modifying the host files and authorized DNS server, modifying the record on the naming servers, caching DNS. It means the ISP level DNS poisoning. So DNS server poisoning, send malicious DNS server IP, and DNS query spoofing, replying with the false IP. All these are the different DNS level attacks, right? So we need to protect the client system from all these. Now moving to the server side attack. When we are talking about the server side attack, we need to check for the data flow control, we need to check for the load balancer, we need to check for the application delivery control, we need to check for the IPS DDoS protector, and we can use the trusted paths and trusted channels, right? So what is data flow control? Data flow controls are the controls which will help us to check the movement of data between the processes and the systems, and it ensures the systems are not overloaded with traffic. Also, the data flow control will help to check the impact of availability of the system, like overload, which can do drop connections, denial of service, distributed denial of service, and then comes the load balancers and application delivery control, which provide granular data flow control based on policies derived on system capacity cache for regularly used data and TLS offload. So IPS and DDoS protector against DDoS and denial of service. So we can use an intrusion prevention system, or we can use a third-party DDoS protection or third-party web application security to protect from server-side attack. So two more things are there which we need to take care of. One is trusted path and other is trusted channel. So trusted path helps us to protect data between a user and security controls such as a login window. So that if we are giving any user a login window, then only the authenticated and authorized user can enter into the system. So we are creating a trusted path. And the last one is the trusted channel. In trusted channel, we protect the data on a link or between communication peer, like creating a VPN or creating a MPLS link. So all these are trusted channel. So by using trusted path and trusted channel, we can protect the server side attacks. Then how to protect the databases? So the databases can be protected. There are some very important terms which we need to understand before that. That's aggregation, inference, data mining and warehousing, data analytics. So these are the four terms in terms for the CISSP exam, which is very important to understand. And then comes review permissions and them. Okay, so in total these are the 6 things which are very important in respect of the CISSP exam. Normally I have seen that they are asking questions within these 6 terms only. It means you need to understand aggregation. So aggregation means combining records from one or more tables to produce a report, right? And then comes the data mining. Data mining and warehousing means a warehouse that contains large amount of vulnerable data. So data mining produces metadata that is more useful. Okay, so attacker normally target those data mining and warehousing businesses also. Then comes inference, deduce a result based on some other data. Like if any particular company is issuing thousands of checks, okay, at the time of the salary, then it can be inferenced that they are having 1,000 employees in their organization. Then comes data analytics. So big data is the example of data analytics. It is mainly focused on extracting information which is interested to that particular business. Okay, then to protect databases, we need to review the permission, and we need to use a DAM, database access management tool. So while reviewing the permission, we are preventing the databases from attack. Also by using DAM, we can prevent these attacks by giving granular access to the database based on the query types, right? So today we are stopping here only, and tomorrow we will again start. Okay, thank you very much friends for watching this, and I'm updating all the slides on the Google Classroom from today, and also I'm updating the questions and the related topic videos from tomorrow onwards. Also in Quizlet I am updating all the terms on regular basis. So as an advice, please keep on watching all these things all together to prepare for your final exam. Thank you very much.